In this video, I introduce you to gases and the gas laws. So what we need to expect to know from this video is things like gas pressure and gas laws. We will try to define what gas pressure is and what it does, and relate that to the gas laws. So let's look at the breathing process and how it is connected to pressure. So the question is, how does the process of breathing work? What information about the properties of gases can we get from this process? So to answer that question, breathing happens because of changes in pressure due to expansion and contraction of chest muscles. So when the chest muscles expand, when they expand, they create a vacuum in the lungs, and then air gets in to fill the vacuum. And then they contract. When they contract, they remove that vacuum, or when they contract, they expel air from the lungs. So it's just a continuous process. Once the air is expelled, the vacuum is created again. So we start another cycle. Then we just keep on breathing. In terms of information that we can get, is that the volume will determine the pressure of the gas, because when the chest expands, the volume increases and then the pressure decreases. The gas comes in to fill the void. When the volume decreases, the pressure builds up and then the gas is expelled, or the air is expelled. Another thing that we can learn from this is that the amount of particles determine pressure of gas. Now, when you breathe in, you are adding particles into the lungs. So there will be so many particles in there. So the best option is for the chest to contract to expel those particles. Because when you have a lot of particles in the lungs, they create a lot of pressure. So that pressure needs to be reduced by expelling the air from the lungs. Now, let's think about you are in an aeroplane going up very high altitude, or landing, going to low altitude from a high altitude. What happens to your ears? I mean, a simple example is even driving up and down the Lewiston grade. You feel something in your ears, some kind of pain. Why does that occur? This pain, you feel it due to differences in pressure between inner ear and the outer ear. So normally there should be equilibrium. The pressure inside the ear should be equal to the pressure outside the ear. If something happens to change this balance, the eardrum is affected, is pushed one way or another, and this gives that tingling pain that we feel when we go to a higher altitude or lower altitude. So in this case, the change in altitude disturbs that balance, and then we feel pain. So you need to understand why we feel that pain. As I already said, driving up and down the Lewiston grade also has a similar experience, because we are quickly changing altitude from a low valley altitude to a higher altitude going towards Moscow or Pullman. So the question is, what is this air pressure? Pressure is a result of constant collision between gas atoms or molecules, and between molecules and surfaces surrounding them. So two types of collisions are happening here. One type of collision is the gas atoms are colliding amongst themselves. That is one type of collision. The second type of collision is the atoms or molecules are colliding with the surfaces of the container or the surfaces surrounding them. In other words, pressure is described as a force exerted by these particles per unit area. So if you have to use a formula, pressure, which is P, is given by force over unit area. Force is given in Newton and area is given in square meters. So the SI unit for pressure is a Pascal. A Pascal is given as a Newton meter. Newton is because of the force here. I say Newton square meter. Newton because of the force here. Square meter because of the area there. So this is the SI unit for pressure. Now let's look at these diagrams. Which of the two is expected? Which of the two diagrams is expected to have a higher pressure? Think of it. So to this question, the answer is that B is going to have a higher pressure. What is the reason? Because it has more particles. Remember, pressure is a result of collisions. Having more particles means more collisions. Now, these are the units that we use for pressure. There are a number of units here, so you can stop the video and study them. But the most important units that we are going to be using in this class is this one, the atmosphere and the millimeters of mercury. And also we need to take note, 1 millimeter of mercury is also equal to 1 torr. So 1 atmosphere is equal to 760 millimeters of mercury, or 1 atmosphere is equal to 760 torr. So a torr is approximately equal to a millimeter of mercury. So these two pressures are the ones that we are going to be using a lot in this class. If you take general chemistry number 2, 112, you will use a Pascal also a lot. So some units, the pounds per square inch, these ones we see them on vehicle tires. So just study them, but focus on the atmosphere and millimeters of mercury. So how is pressure measured? So we measure pressure using two types of instrument. Actually, not two types of instruments, but for this class, we'll talk about only two types of instruments. The first one is the mercury barometer. So let's see how it works. All right. So no internet on me. But how does it work? Here we have mercury in this container, and we have a tube. We fill it in mercury and insert it in this container, and it will create a vacuum up here, and the mercury level will be at this point. So what is happening is that as the air is pushing down, here, the mercury will be going up, and the reading will start from here all the way to here. So for normal pressure, the reading from here to here should be 760 millimeters of mercury. That's what we mean when we say pressure is 700 millimeters of mercury. So That is the atmospheric pressure. But if the pressure increases, if the atmospheric pressure increases, this one will push down here more, and the mercury level here will increase. It will be more than 760 degrees. If you go to a place where the pressure is low, the air will push down here less strongly, and then this mercury level will go down a little bit, and the pressure will be less than 760 millimeters of mercury. Let me see if we can get a video to show that.
Barometer. The pressure exerted by a gas is measured with a device called a barometer. This device can be assembled very easily. For this, we need a long glass tube of 100 centimeters, closed at one end and with a narrow bore at the other. This barometer is filled completely with mercury. It is up-tuned gently into a pool of mercury. When the barometer is inverted, an empty space is created by the tube. This length of the mercury level in the tube is measured starting from the reservoir level. The length of the mercury column is equal to the pressure exerted by air. Under the normal conditions, the pressure is 76 centimeters or 760 millimeters of mercury at sea level. The pressure is measured and represented in terms of atmospheres. 1 atmosphere is equal to 76 centimeters or 760 millimeters, or 1 torr. The pressure of air is generally lower at the tops of mountains and at hill stations as compared to that of the pressure at sea level. The pressure gradually decreases the higher the altitude.
So what we should take note here is that if you go to higher altitude, you have low pressure. If you go to low altitude, you have higher pressure. Actually, the highest pressure that we gauge on the Earth is the one at sea level. If you go lower than the sea level, the pressure will increase, but for practical purposes, we use pressure at sea level as our standard. So we can have pressures higher than the sea level when you go actually deep down the sea. But definitely that will also be combined by water pressure. But in terms of air pressure, we use sea level. As you go up, what is happening is that you are reducing the air column. As you go up, there will be, if you go to Everest Mountain, there will be very little air column going up compared to if you are like at sea level in Florida. So the bigger the air column, the higher the pressure. That's why on the mountains we have low pressure. At sea level we have higher pressure. That's the same reason why people who are like climbing mountains like Everest Mountain, they take oxygen tanks with them because we have very low pressure up there. We don't have enough oxygen for breathing because oxygen is like in short supply at higher altitudes. So you need to have oxygen tank with you to help with the oxygen supply. So as I already said, in this case we have air pressure that pushes down and the mercury pushes up the column and vice versa. We have another type of barometer or another type of instrument we use to measure air pressure. It is known as a manometer. So it's a U-tube of some sort. So let's see.
Gas pressure is usually measured by manometers. The simplest manometer consists of a graduated U-shaped glass tube closed at one end and connected to the gas container at the other end. The tube is filled with liquid mercury. When there is normal atmospheric pressure inside the container, air pushes a column of mercury up to a height of 760 millimeters of mercury. At this height, the pressure exerted by the mercury column balances the pressure exerted by the air. As air is removed from the container, the air pressure is reduced, and the column of mercury drops down. You can read the pressure as the difference between the mercury levels in the two arms. If the container is evacuated completely, the columns of mercury will reach the same height in both arms. Any other liquid can be used in a manometer. However, the height of the manometer depends on the density of the manometric liquid. Water is more than 13 times less dense than mercury. Therefore, the water-filled manometer would need a height of about 10 meters. The use of such a manometer would be rather awkward. Manometers
So in terms of manometer, the air pressure will push us down through the pipe. So if you add something that has pressure here, it will push this pipe and then the level will increase as shown here. So the measurement should be the pressure reading should be given from this level up to this level. So if from this level to here you've gone like 180 millimeters, you say, all right, so the pressure that I have applied here is 180 millimeters. Now that's it about pressure. Now let's look at the gas laws and let's see how pressure affects how we describe the gas laws. So in this video I am going to discuss 4 gas laws. The first gas law is Boyle's law. The second one is Charles' law. The third one is a combined gas law, and then Amonton law, Avogadro's law. That is 5 gas laws that we are going to discuss here. So let's check this animation. Let's look at it properly and see what is happening. You can see we have different volumes here. And let's see how this thing is moving. So the question is, if you look at the two, which do you think is going to have a higher air pressure? So I would say A is going to have a higher air pressure because A has a small volume and you can see it has more collisions than B. So A with a smaller volume has higher pressure than B, which has a larger volume, because A has more collisions. The higher the amount of collisions, the higher the pressure. So what it means is the smaller the volume, if you have the same amount of gas, in this case we have one gas atom and one gas atom. If you have the same amount of gas, the smaller the volume, the higher the pressure. That is the description of Boyle's law, the statement of Boyle's law, which says that for a fixed amount of gas at constant temperature, pressure is inversely proportional to volume. So what is important in Boyle's law? Fixed amount of gas. So it should be the same amount of gas at constant temperature. So 2 things should be fixed. The amount of gas and temperature should be fixed. Pressure is inversely proportional to volume. Mathematically, we say V is inversely proportional to P. So V, the inverse sign 1 over P, or the proportionality sign here 1 over P. That's what it means, inversely proportional. What does it mean? When you increase volume, the pressure is going to decrease. When you increase pressure, the volume is going to decrease. I mean, if you have a balloon and you are squeezing it, you are increasing pressure and the volume will be decreasing. If we remove the proportionality sign here, we can put an equals sign. So V is equal to K, over P. P is pressure. K is some sort of constant. So if we multiply both sides by P, we see that PV is equal to K. Now, let's suppose we have the same gas. We have put the gas under two different conditions. So initially it was at pressure 1, then it was at and volume V. And then we squeeze the gas, and we see that the pressure changes. So it will be at pressure 2, and then the volume will also change. It will be at volume 2. In that case, we can say that because the constant will not change, right? The constant is not going to change. We can say P1 V1 is equal to K, but also P2 V2 is also equal to K. So if we remove K here, we can equate the two. P1 V1 is equal to P2 V2. This is the mathematical statement of Boyle's law. So we need to take note of this. And in terms of using it for math, it's important to understand it. So keep in mind this law when coming to class for gas laws. You need to have this law written somewhere, because we'll go straight into the math concerning the Boyle's law and the laws that we are going to deal with later. So also another important statement: as you increase pressure, the volume decreases, vice versa. That's what it means. Now let's look at the second law, that is Charles' law. This one gives a relationship between temperature and volume. Now look at the animation. So we have gas A at 20 degrees Celsius, gas B at 80 degrees Celsius. Which one do you think has a higher volume? Here clear we see that gas B has a higher volume. What is the reason? Because it is at higher temperature. So B is at higher temperature, therefore has a larger volume than A. As you increase the temperature, you are increasing the kinetic energy of the particles. So there are more collisions. The particles have more collisions, and then because of having more collisions, the particles will push against the walls of the container and therefore increase the volume. So for Charles' law, what you just need to know is that as you increase the temperature, the volume will increase. In terms of a statement, we say that for a fixed mass of gas at constant pressure, temperature in Kelvin is directly proportional to volume. So what it means is that as you increase temperature, the volume also increases. Mathematically, we say V is directly proportional to T. We can remove the proportionality sign and put K. V is directly proportional to KT, where K is a constant. Or if we want to put K on one side, divide both sides by T, we see that V over T is equal to K. This is the statement of the Charles law. But now, if we change conditions, if we have the same gas, but we change conditions of volume and temperature, what we are going to have is V1 T1 is equal to V2 T2. So this is a statement of Charles' law. You need to memorize these statements. They are very important. Memorize them. I'm not providing them in class. You just need to put them in your memory. I'm not providing them in an exam, but you need to memorize them. You need to memorize what Charles' law is, what Boyle's law is. So, this is what it means. You increase temperature, the volume increases. Then we combine Boyle's law and Charles' law. We call it combined gas law. We know that Boyle's law is given as P1 V1 is equal to P2 V2. We also know that Charles' law is given as V1 T1 is equal to V2 T2. If we combine the two, so what we do is just we take P1 V1, right? We already have V1 here, but we don't have P. So if we take P1 and put it here, we'll have P1 V1, which is like this. If we take P2 and put it here, we'll have P2 V2, which is like this. And then just put the T down here. This is what we have. P1 V1 over T1 is equal to P2 V2 over T2. So this is a law of a gas that is changing in both pressure, volume, and temperature. Boyle's law, the changes are only pressure and volume. Charles' law, the changes are only volume and temperature. But in this case, we have three things that are changing here: the pressure, the volume, and the temperature. So also write down all these three laws for the class. Now we have two more laws that we want to deal with, and then in class we'll deal with the most important gas law. The Amonton's law. This is a pressure and temperature law. It is a variation of Charles' law. So let's check the animation. Here we have two systems. The system at 20 degrees Celsius, the system at 70 degrees Celsius. And we see we have P1 and P2. So let's see what happens. This is 20 degrees Celsius and this is 80 degrees Celsius. Do you see how many collisions for each one? We can see that at 70 degrees Celsius there are so many collisions compared to 20 degrees Celsius. This one has more kinetic energy and therefore can produce a lot more collisions and therefore higher pressure. We can say that B, which is at higher temperature, has a higher pressure than A because B has more collisions. In terms of a statement, the Amonton law says that for a fixed mass of gas at constant volume, pressure is directly proportional to temperature. Mathematically, P is proportional to T, or P is equal to KT, or P1 T1 is equal to P2 T2. So as a reminder, you can relate this to V1 T1 is equal to V2 T2. So in this case of P1 T1 is equal to P2 T2. This is a statement, a mathematical statement of the Amonton's law. And it means as you increase the temperature, the pressure increases. So I'm putting these statements on purpose. You need to take note of this. The last law that we are going to deal with in this video is the law that relates volume and amount of particles. We call it Avogadro's law. Avogadro's law states that volume of a gas is directly proportional to the number of moles at constant temperature and pressure. So what you should take note is that when making a law, we need to make some of the variables constant. In this case, the pressure is constant and the temperature is constant. Mathematically, volume is proportional to number of moles, or V is equal to constant times number of moles, or V1 N1 is equal to V2 N2. So this is the statement of the Avogadro's law. So as a reminder, in chapter 2 we talked about the fundamental gas laws, and we also talked the fundamental laws of chemistry, and we also talked about Avogadro's hypothesis. So if you look at this Avogadro's law, you see that it is similar to the Avogadro's hypothesis. Avogadro's hypothesis says that equal volumes of all gases at the same temperature and pressure have the same number of molecules. So you see, this is a volume, this is the number of molecules. That's the mathematical part. This is the mathematical part of the Avogadro's hypothesis. So make sure you understand this video and do the assignment that has come with this video. We are not repeating this in class. We'll just quickly go over the problems that we can solve using these gas laws. Thank you.